Welcome back to Cricket Aviation. My name is Jim Payne. If you've watched some of the videos I posted recently, you may have noticed that those videos were still in my old shop. And if you noticed that, you'd be correct. This is actually going to be the first video that's being recorded in my new shop. So the good thing is I've got my CNC machine working well. I've got all of my equipment so I can actually use it on benches instead of on the floor, which is actually what I was doing before. So what I'm planning to do is a series of videos now with, starting with this one, with the goal of being able to get everything done on this airplane with the exception of all the fiberglass components such as the, fairings and cowlings for my engine, for example, and the canopy and the wings. So I'm trying to finish everything in the fuselage. That's all the controls, everything to do with the engine mounts and frame one, which we're going to go over in this video, and get all the flight controls ready and working and connected, rudder pedals, that type of thing. So that's what we're going to cover in the next series of videos. But in this video, what I'm going to try and do is cover everything that finishes up what's attached to frame one. So when we built the fuselage, I never finished some of the brackets and some of the supports that needed to be installed for the engine mount. So we're going to go through creating all of the supports for frame one for the engine mount. We're going to create the aluminum supports that the steel engine mount mounts to. We're going to install the steel engine mount, and then I'm also going to go over some of the things that I've done to create the aluminum supports or aluminum mounts that attach to the steel engine mount for my turboprops. The steel engine mount is identical to the one that is in the plans, and I'm not going to go over actually the construction of that steel engine mount because it's a bunch of pieces, pipes, and stuff that's welded together, and I didn't make this engine mount. So John at Northern Machining actually made this mount for me. He had found somebody who could actually cut out all of the steel parts on a laser cutter. So John has arranged to cut out all the steel parts. He actually welded this one for me, and this was kind of our prototype engine mount that I am testing here on my airplane. And you'll see in the video if you watch it, there was a couple of issues that we found that we worked around. But again, this was the prototype, so we have taken all of those issues or things that we have found in installing this engine mount on my airplane and applied it to the engine mounts that will be built in the future and the form that John is using to make these engine mounts. So these steel engine mounts, we're planning on having these available on the website, but for now we're just doing the testing at this point. But the hope is that these engine mounts would be able to be purchased from the website, completely welded just like mine is here. So you'll get to see that in the video. The aluminum brackets that I had to make, we're going to go over how to make those in, basically by hand. I did all of that on my mill behind me. So let me grab the camera and I'll actually show you here. Okay, I'll show you a little bit up close before we actually get into the details of the video. But you can see the engine mount that I created here out of aluminum. And what we're going to do is taper the front edge of this, similar to what's in the plans for the single cylinder piston engines. This will actually end up being the support for the engine cowling that's going to go on here, and we have a place to screw that cowling onto at least the front. There'll be brackets in the back. But you can see this is the standard steel mount that is for the CriCri. You can see the aluminum support mounts here for that steel mount that it bolts to the frame one, and then you can also see the frame one stiffeners or supports that attach to the upper fuselage skin. Let me think here what else I can show you. So I did create these supports for the cover or the airfoil shape that's going to go over and cover the top of these this engine mount that sticks outside of the aircraft. And I did just create a little test piece that I could put over the top of here. Some of this stuff isn't really labeled well in the plans or shown in the plans of what we're actually going to bend and create over that covers this. And this is a support that's just going to support the bottom half of the airfoil. That cover is going to come all the way up here, and then we actually will taper this edge here on this engine mount and put a screw in here at the top to support that that pylon cover, basically. That's my lower mount down there that you can see. So I've got the entire engine mount completely installed. I've got all the aircraft hardware on it. The only bolts or nuts that I haven't put aircraft hardware on is these here, because I'm taking these constantly on and off as I'm testing things, and I'll have to take this off to be able to slip on the pylon covers. But what I tried to do here was get everything done to the point where I can now start creating the fiberglass nose cone. I can then start working on these pylon fairings, and then I can start working on actually creating the engine covers for my turboprops. Now, some of you may be asking, why did I go ahead and build this mount the way I did, and why didn't I come up with a new mount specifically for my turboprops? And I would say the reason is that I think no matter what engine you're going to use on this, whether it's the single cylinder pistons, or you're going with a 2-cylinder RC type of airplane engine, or you're going with a jet engine, or you're going with the turboprops, I think this mount is good enough to use for any configuration. And then the only thing that you have to modify is this mount here, depending on what engine you're actually going to use on the airplane. So I tried to stick to the plans as much as possible, with the only thing that's different is this mount here. Everything else within the rest of this engine mount assembly is per the plans, including these bolts that John made for me on the lathe. These are the steel mount bolts for the aluminum brackets that support the engine. Now, if you've seen the plans, there is a very complex method of actually installing the single cylinder piston engines. And I think it's something that we should talk about, because it's very confusing in the plans how those engines are even supported. I'm going to actually show you in a minute here on the computer how this actually works. But those engines, if you use the single cylinder ones, and some people have done this also with the twin cylinder ones, is the designer tried to do as much to limit the impact of vibration on this steel engine mount, because over time a single cylinder engine shaking on here is eventually going to crack the welds on this, and you're going to have problems in the long run. Plus, you don't want to transfer all of that vibration from the engine itself into, directly into the airframe. So the single cylinder engines are actually connected to a aluminum framed bracket similar to this, with 4 wires. Now, what I mean by wires is they're 3mm piano wires, so it's a solid piece of wire. But those engines are actually connected on the back to a plate on the back of the engine. There's 4 wires that come through. Those 4 wires would come through this aluminum plate and actually clamp and bolt onto the front. So that engine is not bolted directly to this. That engine is connected with 4 wires on the 4 corners to a plate that's on the back of the engine, so it can freely float somewhat on the engine mount. But then what they've done is that the front of the engine is actually connected to a rod that goes down and actually goes over the top of these bolts, but doesn't touch it, doesn't connect to it. There's actually big holes in an aluminum rod that goes down each one of the V parts of this engine mount, and it just sits on the front, and then it's strapped to a plywood, basically a plywood interconnecting plate that it's strapped to these aluminum rods that go up and connect to the front of the engine. So if you're using a single cylinder engine, you're actually connecting each one of the engines together through 2 aluminum rods that are bolted to the front and then strapped together with a plywood connector in the middle. And so what that does is it connects the 2 engines together, but gives it some suspension vibration capability of absorbing some suspension of the vibration of the engines. And it obviously is then transferring, or I shouldn't say transferring, but it's hoping to, with the engines connected together, that the vibration will cancel each other out. So vibration on this engine will be transferred over to this engine, and they will kind of calm each other down a little bit depending on the RPM that you have them set to. But that's kind of the way this thing works. And it's very confusing actually how the engines are really supported.
What I've got open on my computer right now is drawing 500 and drawing 501, which kind of illustrates how the engines are supposed to be installed on a CriCri. And if we start out here, you can see in the center of this drawing right here is the steel engine mount, which matches the exact engine mount that I'm using. So I've tried to stay with the standard engine mount for the configuration of my engines, even though I'm using the turboprops instead of the piston engines, which are in the plans. Now, what I have done though is I have eliminated the interconnection between the right and left engine that is in the plans that's designed to help the piston engines absorb some of the vibrations that can occur with the single cylinders on a CriCri. So I have this steel engine mount made, and what I did is I substituted an aluminum engine mount that I made that specifically fits my turboprop engines that you can see over here. I'm using the same style of mount, the same design of a mount, but what I've done is I modified it so that my turboprop will mount to it versus how the mounting of the piston engines is done on these aircraft. Now let's take a look a little bit closer about how all of this comes together. So if you look at the top here, you can see this is the steel engine mount looking down on it from the top. These are the bolts that support the front aluminum engine mount plate that I have made. So I'm using the steel mount, I'm using these same standard bolts, and I've made a substitute aluminum mount for the front of the engine. Now if you look at these drawings carefully, you'll actually notice though that the engine itself is not bolted to this aluminum mount that I have created for my engines. In fact, the engine itself is only connected to this steel engine mount and this aluminum mount in the front by 4 wires that are attached to the rear part of the engine. So if we look at this drawing here in the center, this right here is the aluminum plate that I have made, or basically I've replaced, is this aluminum plate here in the front. But you can see this engine actually is not bolted to this aluminum plate at all. What they have here set up is there's 4 little clamps that mount to the front of that aluminum plate, and then there's 4 wires that come through that plate and attach to a bracket on the rear of the engine. So if you remove the interconnection of the right and left engine, the engines are actually just hanging on to this aluminum bracket here at the front that's attached to the steel mount through a series of 4 3mm what they call piano wire pins, which are the wire that is basically very difficult to bend. It flexes a lot before it bends, but that's all that's actually attaching the piston engines to the airplane. Everything that goes on after that is the engines themselves being connected to each other, but even that interconnection that connects to each other does not connect to the airplane at all. So again, the only thing that is holding these engines onto the airplane is these 4 wires. Now, obviously the 4 wires are fairly stiff, so it's going to hold it on there fairly well, and it's going to allow the engine to vibrate a slight amount. But if we didn't have the interconnection with the single piston engines, they would still shake so much that it would cause issues with these mounts. And I'm not sure that these 4 pins would even be able to support the engine on its own if it didn't have this interconnected system to try and offset some of the vibration from one engine to the other. And the idea here is that it cancels each other out a little bit. So what you'll also see on the front of this engine, if we go up to this drawing up here, you'll see from the top here there is a rubber washer that you're supposed to make on the single cylinder engines with a gap of 2.5 millimeters all the way around that fits inside the center hole of this cutout of this aluminum mount. And I'm assuming what's supposed to happen there is that if these engines vibrate enough, you don't want the metal engine to be hitting the aluminum bracket. You want some kind of cushion in there, and they're using that rubber washer so that if the engine shakes enough, it will actually hit and get absorbed by the vibrations will get absorbed, and the impact will get absorbed by that rubber washer that goes around here. But again, this engine is not directly connected to the front of this mount. So how are these interconnected together? So you'll see here in this drawing there is this aluminum plate right here that travels down the front of the steel engine mount. It's not attached to it, but it's attached to the front of the engine and bolted to the front of the engine. And if we jump over to drawing 501, that is actually this mount here. So this is what's connected to the front of the engine. It goes over the top of the 2 bolts that hold our aluminum bracket in, which this is the aluminum bracket here. That's the standard one for the JPX piston engines that is bolted to the steel mount. But those bolts that go through, this actually just passes, the bolts actually pass through here and don't connect to it. It's just supposed to float within it. And so this aluminum mount travels down the length of the steel mount, and this mount is connected to another mount to the other engine through a plywood, basically a plywood interconnector. which in this drawing up here, you'll see it here, it's actually mounted to the front, and these are actually screws with straps or rubber bands that connect the aluminum bracket to the wooden support, which is located here. So this is the wooden support that's supposed to go across the center that connects the aluminum engine mount bracket on the left engine to the aluminum bracket on the right engine, and they are strapped together. So the two engines are connected at the front, connected together, and then through a series of rubber bands and used kind of as a clamping method, they're connected together physically. But again, there is some shock absorption available there because the aluminum arms will actually float a little bit within the rubber bands that connect to this plywood interconnector at the bottom. And so again, it's not connected at all. And let's see, you can see in this drawing here, this is that front arm that's coming down, connected and bolted to the front of the engine, that then follows down the front of the steel engine mount, but it's not connected to anything. In fact, the only thing there is up here at the top. You'll see a little, I think it's a piece of wood that they have you glue to the front of the steel engine mount, so in case this vibrates enough or shakes that it won't bounce or hang or hit on the steel mount, it'll just continue to float back and forth on the front engine mount. So it's a very ingenious way of trying to get rid of as much vibration as possible. It's amazing to me though that this all actually supports the engines themselves, because again, there's a lot of force that's going on here. The weight of the engines with G-force is pulling them down. Again, they're not they're interconnected together, but they're only connected to the engine mounts with these 4 pins. But again, you do have a propeller that's providing thrust forward, so much of the pressure is pushing forward on this mount, not down or up or sideways, because again, the forces are being offset by the propeller thrust. But again, it's a very interesting way of doing it. Again, I've left all of this interconnection stuff off of mine because it's unneeded, but it is something you might want to think about if you're using any kind of piston engines on a CriCri, that you could use this method of interconnecting these engines together to try and prevent some of these stresses getting into the engine mount and or the airplane, and possibly having issues with your engine mount cracking or welds breaking, because again, you've got so much vibration. So what we're going to do now is let's go back and actually start the video and start going through the process of finishing up frame 1 and installing this engine mount, and we'll go through the whole process. So that's what we're going to do next. So what we're going to start working on today is the aluminum portion of the engine mount that mounts to the front of frame 1. So there's some 8 3/4 inch aluminum brackets that we need to make that are kind of a T profile, similar to the other fittings that we've had to make for the CriCri. So what I'm going to do is start out with this 1 1/4 by 1.5 inch solid piece of 24-inch long 2024 T3 aluminum. I'm going to go ahead and start by cutting 2 8 3/4 inch pieces for each one of the side brackets that mounts on frame 1. So I went ahead and cut out the 2 pieces that I need to start out with. These are again 8 3/4 inches long. That's longer than what we actually need, so we'll be trimming these off a little bit once we get the initial form created here. Now what we're supposed to do is take this and create a T-stock. So there's supposed to be a 4mm raised part in the center here, and there's supposed to be a 4mm flange on both sides. And so we're just going to go over to the mill and we're just going to cut out the area on either side and create that initial T-stock, and then we'll start shaping that down further. Now, one of the things I did want to comment, in a lot of cases when you're working on aircraft projects like this, a lot of times you're working with 2024 T3 and you're also working with 6061. Make sure that any cutoffs that you have left, that you either keep the painted end or you paint the end of it, so that you know when you come back to it later on whether it's 2024 T3 or it's 6061. Obviously they are not the same strength, so I usually like to keep the end that's already painted from the
you know, the supplier that I purchased it from, but you can also have a spray paint can in your shop of both blue and red. Usually you mark 2024 T3 with red and you mark 6061 with blue, just to make sure that you don't mix the two materials up in your shop. So let's go over to the mill and we'll go ahead and start cutting these out, and I'll show you what it looks like when they're done. Okay, well here's the initial preliminary cutout of the engine mounts. So these are 4mm T-section. I've just, you know, cut these out of a solid billet piece of aluminum, and they're to the correct width and to the correct height. But now what I have to do is I've got to taper some of these edges. We've got to drill some holes. We've got to cut down some of the other edges. So this is just getting the initial stock so that we know what we have to work with. This took hours to do. I'm just using a manual mini mill, and obviously these are fairly long, so taking swipes back and forth on both sides of these, you know, and trimming these up. This took a while. So, but these are done. Now, you'll notice that there's no radius on here. I couldn't find anywhere in the plans where it indicated that there should be a radius on these parts. And of course, you would think, well, you know, if it's structural, they all should have a radius on it. But I don't believe the designer is requiring a radius on these, especially when there are some steel plates that are bolting onto this. And I did verify that the steel plates are supposed to go all the way down to the base of this angle here. So if there was a radius there, it would hit it. And again, like I said, there's no profile section like this of what these are supposed to look like, but the designer did not draw radiuses on these corners. So I'm going with the assumption that we don't need them. I don't believe it's necessary on these anyway, since you know, the loads I think are almost completely vertical up and down and straight out. I don't know if there's any real bending forces on here, kind of like a spar would have. But anyway, so I'm going to go ahead and start marking these and see if I can set up my mill to do the taper across the front here, and then we have to actually cut a 12mm slot that goes up here, or diameter wide section that goes up here where the taper comes down. And these are kind of supposed to be funky looking. In fact, let me just show you on the manual, you can see what they look like. So this is what we're making right here, and you can see I've got the general shape, the 34 by 26. But we got to angle this all the way down, and then cut this out and angle these sides down. It's going to take a lot more work to get these the way they need to be. We also need to cut a slot in here for cables, I guess it says. So yeah, let me just start marking these parts up and see if I can get some of these other sides of these trimmed up and milled up here. So I'll show you what it looks like in a few minutes. All right, I finished the next step, which was tapering and making these angles on the this center part of this T-stock. So now what we're going to do is I'm going to flip this over in my mill, and we're going to mill a 12mm wide path here, and then we'll angle that back up to the corners to just finish off the actual shape. Then we'll go back and we'll start drilling the holes that need to be 3 holes in here. There's going to be 1 down here at the bottom, 2 on the top for mounting, and then we've got a bunch of holes that are going to go along here for actually connecting the actual engine mount, steel engine mount itself. But I'm just trying to get this point to the point where I can mount this on frame 1, which really just requires that I have these 3 holes in here. So let me go back and I'll keep milling these a little bit more, see if we can finish up the initial shape here. Well, I almost made a huge mistake. So it turns out these are not supposed to be symmetrical side to side. The holes here at the top are actually offset one direction, 2mm each side. So this side here, or at least, you know, obviously there you have to make one that's a mirror image of the other one, but one side is supposed to be 16mm from this 4mm flange to the edge, and the other side is supposed to be 14mm from the edge of this 4mm center section here to the edge, and the holes up here are supposed to be offset that 2mm. Now obviously I was making these symmetrical, but I did give myself just a little bit of extra material on either side, you know, for final, you know, trimming out and everything. So it looks like I do have enough material here to fix these so that I can make sure that I do have this center part here actually offset basically 1mm, I guess it is. Let me look at the drawing here. Yeah, so what I missed here is I was looking at 34mm wide which I did. I was doing the 12. I was putting this center in here, but you can see this hole is supposed to be 12 millimeters from the center, and this one's supposed to be 10. So there is supposed to be these are supposed to be made offset. And then I did go over and find, I guess it was this, no, see this drawing here, because I was trying to figure out, okay, well, which direction is this supposed to be offset on frame one? And you can see, according to this picture, it looks like the bigger side, or the hole that's offset further, is actually on the inside, and the outside is, so the 14 millimeters from the edge is supposed to be on the outside, the 16 millimeters from the edge is supposed to be on the inside. So I have to make these in a mirror image fashion here. So I'm going to go and see if I can fix these and start these tapers here, but I'm going to have to make sure I take a little bit of material off on the holes up here on the one side, and make sure I leave a little extra material on the other side. So this is what the completed aluminum engine mounts look like. I was able to fix and finish the offsets that needed to be done here on the top, so I do have these holes positioned properly with the correct distance from the center line. Luckily I had enough material to do that, so I just went ahead and finished drilling all these on the mill, creating that slot in the mill, and yeah, so these are basically ready to be installed at this point. So we're going to go back and head over to frame one and start working on the actual brackets that mount behind frame one that these bolts will attach through and connect to. These are the brackets that we need to install behind frame one that attach to the aluminum T-profile engine mounts that I just showed you previously. These actually need to be bent. This is made out of 80 thousandths, so it's fairly thick. This is going to be pretty difficult to bend because we do have to bend a 90-degree flange that comes down here on frame one, and it also has to have a joggle in it to go over the frame one skin, and then these mount on the bottom of frame one down here and go across the bottom skin, and then are bent up and then connect to this hole here that aligns with the bottom of the engine mount aluminum bracket. So I'm going to work on trying to bend these to see if I can get them to fit behind the skin here on the upper skin of the fuselage and the lower skin of the fuselage for frame one. I removed the skin from the forward fuselage here, and I started to work on bending these brackets that go on the bottom of frame one and on the bottom skin. And you can see I placed one of them down in there. This is the bracket that goes behind the lower bolt on the engine mount. So I've got both of these bent. I just bent them on the vise. It's pretty easy, and I just put a joggle in there by putting some material underneath this side, and then clamped it in the vise. I did put some tape on the front of here and drew a line down the center. What I want to do next is actually put this where it needs to go, right about there. And then what I'm going to do from the front side, because I had my CNC machine actually drill a 16th inch hole here where the mount is supposed to go, and so I'm going to look through this hole and just see that line behind there, and I'm going to drill a hole into that little bracket so that I can pin it into place with a cleco. Once that's done, I'll come back over here and I'll get in here with my drill, and we'll just drill out those 3 rivet holes and put clecos in there to hold that. There is a doubler, or a plate that's supposed to go on the back side of where this bolt comes through for that engine mount. I think the lower one is 1/8 inch thick. It's just kind of a shim washer that helps support the nut on the back side of there and add a little bit more support. The upper bracket that goes up here that I showed you earlier also has a plate that goes on the back that's thicker than that. I think it's 0.160 that needs to be put on the top there. So once I get these pinned in, I'll go ahead and create those little supports or washers that go on the back of there, and I'll show you that when I get to that point. Well, I ran into my first problem with trying to get this engine mount installed. I just thought I would point this out here. It appears to be a mistake on my part. I'm not exactly sure, but I've got the holes pre-drilled, 16th inch holes here at the top and one at the bottom here for the aluminum mount that mounts the steel engine mount. Now what I did though is on the CAD drawings, I went ahead and drilled and marked those holes into the sides of the frame, one on this side, one on this side, but I didn't do anything to mark that on the top. And the reason for that is I knew the dimensions from here down to here of exactly what that bracket is supposed to, how that bracket's supposed to mount and where those holes are supposed to be, but I wasn't thinking about the fact that I really needed to be also concerned with the fact that, of how wide these are. And of course, I've got the steel mounts down here with the aluminum brackets mounted on there, but the steel mount, obviously these holes for these aluminum mounts have to go exactly where they line up with the steel mount. Now the steel mount was actually made perfectly. I measured it. It's 160 millimeters from this hole to the inside hole of this hole, but these holes on frame one here are actually about 2 millimeters off. They should be 2 millimeters further out on both ends of frame one here. So what I'm gonna have to do is, it turns out we're putting a number 10 bolt in here. And so I only have a 16th inch hole here. So I have the ability to move this hole over and still have this existing 1/16 hole fall in the middle of our number 10 hole that we need to drill. So it's something that's fixable. I'm just going to have to walk these holes over a little bit or drill a hole, right next to it and widen it out from there and, make sure that this gets moved over. I'm just trying to make sure that everything's going to fit right here and that I actually have the mount so that it fits without any tension against the existing brackets or the aluminum brackets that we have to install and, frame one. I didn't want to just mount those brackets here and then try and get the steel mount to fit. I likely wouldn't have in this case, obviously, so I'm trying to actually now fit the brackets and the mount to frame one into whatever configuration that ends up being. But like I said, the holes line up perfectly or are measured perfectly on the aluminum brackets when they're mounted on the steel mount, so it's just a matter of me getting these holes in the right spot. So I'm gonna go ahead and move these holes over and see if I can actually get this temporarily set into place. I don't have the supports bent up here or installed yet because I wanted to make sure that these holes were in the right spot first before I installed those, and tried to drill the holes and cleco them in. When obviously if I had done that, I would have been off. So let me go fix these holes and I'll show you what it looks like once I get this mount temporarily fit onto frame one. I was able to drill out the holes for these aluminum mounts for the engine mount and actually temporarily get the engine mount mounted up and installed. Now I ran into another problem here, and what I'll do is I'll call this a prototyping issue or prototyping mistake. So this lower mount that goes in the front here is supposed to have basically a standoff, a shim, whatever you want to call it, right here that gets mounted across the bottom and goes across the top, and then this angle is supposed to sit on top of those shims there, and then there's supposed to be a bolt that goes through this bottom mount on the steel engine mount to these aluminum brackets to attach the lower part of the engine mount. Now what we ran into an issue with is that when we did the prototyping and actually set up the jig, we forgot to take into account that this bracket down here was going to be sitting on top of these 1/8 inch shims. And so what we ended up with is that this support down here is actually 1/8 of an inch too far in towards frame one, so that with the shims underneath these brackets, the holes don't align for the engine mount. Now what we're doing obviously is we're changing the jig that we have so that this problem doesn't happen again, but now I got to figure out what I'm going to do with my airplane, and I really don't want to scrap this engine mount, which was obviously a huge amount of welding and and work that had to be done to create this. Now I think there's a simple solution. So what I'm going to do is I'm going to go ahead and use these brackets that I already created. I'm just going to mount them right on the front directly to frame one, and what I'm going to do is take these doubler supports and actually relocate them behind frame one, right back here where the bolts come through for the nose gear box. So what I'm going to do is just mount these back behind here. The bolts will still pass through the front bracket, through frame one, and then in through these supports that are behind it. I really don't think structurally it's going to make one bit of difference. And so I think it's a quick and easy fix to at least continue to use this mount on my airplane. So what I'm going to do right now is go ahead and start shaping these. I'm going to bevel the edges on this so that it fits in behind the nose gear box there and fits properly, and make sure that I can get those in there properly. And then we'll go ahead and see if we can finish assembling this. I do have some, there's like some washer shims that you have to make out of aluminum. They're like little standoffs that go in between this mount here, which it's actually offset from the actual steel mount where the bolt goes through. So I'm gonna go ahead and make those two and just see if I can fix all this down here so that this is all fitting properly. And then we're gonna go back to doing the additional supports that need to be attached behind the lower and upper mounts here that attach to these skins on the top and the bottom. I'm just finishing up creating the brackets that attach to the bottom fuselage for the engine mounts. So this is the doubler plate that I'm putting on the back, and I just made all these by hand. I just had scrap material that I just cut out, just put it on the sander here and just got it to shape. And that basically is going to attach right behind here, and we put the nut that goes on the back side of the bolt that goes through the bottom engine mount. So you can see I have this one installed already on the left side. I'm going to go ahead and finish the one on the right. And you can see, just never pay attention to the hardware that I have installed. I always install just regular nuts and bolts from the hardware store just to get things held in place so I'm not chewing up my expensive lock nuts. So I'm going to go ahead and get this one installed on the right hand side and start working on the upper mounts. I was able to get the first upper support bracket here bent. I did use the annealing process where I put a Sharpie, marked it with a Sharpie, and then heated it up until the Sharpie, started to, for the most part, disappear, and then stuck it in water to quench it. I was able to bend this just fine. I also was able to get a slight joggle in here, which is good. So this will fit right behind here with the joggle being able to bring it back up to the height of the skin. And then I put a straight edge across here to make sure that this was at the right angle. So what I'm going to do is I'm going to try and mount this right behind here. So this bolt here and the two top bolts of this bracket are going to go through this attach fitting here. But so is this rivet that's on the right side of the top of frame 1. So what I'm going to have to do is drill this out because this actually has to go right here, and what we'll do is we'll drill a new rivet hole through this bracket here and then go ahead and pop rivet all the way through this at the same time that we drill the holes in here for the bolts. So I'm going to try and get this one installed, and then I'm going to go ahead and bend the one on the right side here, and I'll show you what it looks like when I get one installed. I have both of these upper engine mount supports installed now. I've got all the holes drilled for the mount itself and for the rivets that are going to go through for the front of frame 1 and the skins. And so these seem to be bent pretty well. I was, making sure that I come back and check, make sure things are smooth across here between the edge of the fuselage here, these tabs that are sticking out here for these supports, across the center support here on the upper fuselage and across the other side. They look pretty good. That's going to be critical to make sure that the skin isn't rippled up here, is to make sure that these are nice and smooth and conform to the shape of the front here. So what I'm missing though is there's two additional shims that go behind here that the bolts go through. That's supposed to be made out of .160 material. So what I'm going to do next is go ahead and cut out those little shims and see if I can fit those in. And basically what those are is they're exactly the same as the shims that we put underneath these nuts in the back here. Just an additional bolt support that clamps through frame 1 here. I'm going to go ahead and make those, and then the only other thing I have left is I've got to make these little bushings that go inside of here to fill this gap between these brackets and the center engine support. I just got to make those on the lathe, so I'll probably do those after that. And once those two things are done, we're really done with most of the engine mount specific stuff as it relates to frame 1. So then what I'll do is I'll take this all apart. We'll go ahead and paint and prime the steel engine mount itself, get it all cleaned up. There's some surface rust that ended up on here from some oxidation from it sitting for the last year. And then we'll make sure we get all the right hardware, and I'll probably go ahead and just bolt this all together permanently. This is one of the things I wanted to get done to the point where it's installed, and we can just move ahead with, again, finishing the rest of the stuff in the front of the fuselage here so we can get the skin finished. So this is what the washer shims
plates or whatever you call them that go behind the engine mount here, that mount behind these tabs that we created. This just bolts behind there. I still have to drill the holes through it for this side for the engine mount. So I'm going to go ahead and finish this one up, get it installed, and get the temporary bolts in place. So I went ahead and cut out on my lathe these 2 spacers that go at the bottom of the engine mount here. Between this mount, they're just supposed to slip in here on either side. Now, I'm not going to install these spacers yet. As I think I mentioned before in the earlier video, I made these brackets early on when I built frame 1 with the intent of using this bracket to make this engine mount. But because I was able to have John weld up this engine mount for me, this hole didn't quite align exactly with the hole in the engine mount. And I would have expected that to happen. So just because this should be drilled at the same time that you're installing the engine mount. So what I'm going to do in this case is just make some new angle pieces here. They're very simple to make. I just made them by hand before. I'll go ahead and install them as kind of recommended in the manual, where I just leave the complete angle intact. And then I'm going to go ahead and run a 1/4 inch drill bit through the hole on the steel here and mark it or drill it through the angle while it's bolted to frame 1. I'll do the same thing with it going the other direction, and then we should have a hole that then lines up with these brackets here and the base of the bottom mount on the engine mount. So I'm going to save these until I get this material in. I don't actually have any of these angles in stock, so I'm going to have to pick up some aircraft spruce. As soon as I get that in, I'll go ahead and make some new one of these new brackets here. We'll go ahead and drill this out, and we'll get this installed. And I'm also going to make sure that I get all the hardware that I need to finish all of this. And that's primarily going to be the next step, is to get this all disassembled. We'll go ahead and finish making those parts. We'll get everything cleaned up. We'll put everything back together, and we'll go ahead and put the aircraft hardware on there, and we'll be good to go. So when I come back, we'll finish this up. I started to play around with making an engine mount for this King Tech turboprop. I did some drawings on my computer in CAD and cut this out on my CNC machine. I'm actually really happy with the configuration. I think this is kind of the direction I want to go. This is in no way final form, but this was to just try and mock everything up, see how it fit together, see if this made sense for actually supporting the engine on the airplane. It's super strong. This is all made out of 1/2 inch 6061. I didn't have any 2024. And I'm not so sure with this turboprop that I need to bother with 2024, just because I'm not dealing with a lot of vibration. I'm not even dealing with a lot of weight. This is overkill as it is, I believe. And obviously 6061 is a fair amount cheaper. So I think I'm going to keep moving forward with this, but I am going to cut another one out. I found a couple problems with this configuration, and part of it's due to this prototype steel mount that's been installed here. We obviously had this issue down here with the spacer not being in our jig when it was welded, which is fine. It's not even a big deal. Like I said, I'm just going to work around it. It's not worth fixing the mount or changing the mount, but we are fixing the jig. But the other issue I found is this tube on both sides is about 3 degrees tilted up further than it should be. We're not exactly sure why. I actually figured it out because if you look at the engine, this top of this mount here should be exactly level. And it's actually tilted 3 degrees, and then I went ahead and put a laser level on the bottom of each one of these tubes, and they're exactly 3 degrees off too. Now, all of the steel parts that we made for these brackets that are welded to these tubes were all done in CAD. They were all cut out on a laser cutter. They're all very precision made. My mount hole down here, other than being an in, doesn't seem to be off, so I'm not exactly sure how we ended up with 29.6 degrees instead of 26.6 degrees. So that's one of the things that we're going to look at. But obviously being a little bit up and down here, if these brackets are in the same spot, is going to tilt these a little bit, but wouldn't think it would be 3 degrees. Anyway, what I'm going to do is I'm actually modified my mount here in my CAD drawing and actually modified this angle here by 3 degrees so that if I make a new mount here, I can make it so it fits and the engine is perfectly level. You wouldn't even notice it if it wasn't for the exhaust coming out the top and the bottom, which is a little bit tilted this way towards the airplane. So I think I'm going to fix it. Like I said, this isn't the final form of this mount anyway. So I have one side of the new bracket that I've made for the lower engine mount
installed, bolted in, and the mount itself is very secure just from the upper mount, so it doesn't move at all. So what I'm going to try and do is I picked up a long 1/4 inch drill bit at the hardware store, and what I'm going to attempt to do is use the hole that is here in the engine mount and run this through the hole, making sure that this is level not only this way but also down this way, and see if I can at least mark that hole where it's supposed to go. I don't think I'm going to try and drill all the way through with this drill bit, just because I think I'm going to get some chatter and it's not going to be a clean hole. So I'm going to try and mark it, probably take the bracket off, put it in my drill press, and go ahead and drill the hole out, and then hopefully install it back in here, and it'll hopefully line up. We'll see. I'm going to go ahead and make my first attempt at doing this, and we'll see if we can get one side done, and then I'll go ahead and make the other side. This is going to be harder than it looks. I'm going to go right there. All right, well that looked good. Let me go ahead and pull this out now. Let's see. That's close to where it needs to be. Well, there we go. Well, let's see how far off we are. Let me grab this drill bit. Let's see if this will fit. Well, the hole's actually a little small. Okay, well the alignment looks perfect. I'm trying to figure out how I used a 1/4 inch reamer on that hole, and this 1/4 inch drill bit does not fit. And it looks pretty level, so I'm going to go ahead and drill that out with this bit, kind of like I said I wasn't going to do. But since this lines up pretty good, let me check the alignment this way. Yeah, that alignment works. That looks perfect. It's level both front to back and side to side. All right, I'm gonna go ahead and make the other bracket, and then what we'll do is we'll drill through this bracket, through the center, and through the other one at the same time. It should help align all those holes all at once. So let me go ahead and make the other bracket, and we'll come back and take a look at it in a minute. Well, I got the bracket in for that lower mount on the right hand side, and I did the same thing I did on this side, and I marked it, drilled it out, and then I final drilled it with the long 1/4 inch bit that I have. So I've got that bolt just slid into place, and it looks really good. I got it nice and straight, so pretty happy with that. That's the bolt that I ordered the wrong size for. In fact, that's just a temporary 1/4 inch bolt that I had that was extra long that I stuck in there, but I've got to order the correct size bolt. But what I'm going to do now is go ahead and take both these brackets off, you know, chamfer the corners, and go ahead and round off and cut out the front of this to match where that hole is drilled, and round it out, kind of like the old brackets were, which was, you know, these here. So I'll make them look a little bit more like this, and then we'll allodyne them and be able to install them. So I'm going to keep working on a few other things here, including starting to clean up this engine mount so that I can paint it.
I took these two brackets for the engine center mount. I just bolted it together through the hole that I already drilled. And what I'm trying to do is just clean these up. So what I've done is, since I bolted them together, I put these in my disc sander and I just sanded the edges all square all the way around, just checking with the square on the ends here and checking the width to make sure that I've got the exact width all the way around. Now that I've got all the ends the correct dimensions, what I'm going to do is set this in my mill, and I'm just going to mill down the top here because obviously I've got a lot of extra material here that needs to be removed. I'm going to remove all of that and then just go back to my disc sander and just angle the edges here just to get a nice smooth shape around the end here to kind of match what I had before. But I'm going to keep cleaning these up. I should have these done in just a few minutes here. Well, here's what it looks like with all the rough shaping. I'm going to go ahead and just clean it up with some sandpaper and some Scotch-Brite and get these alidined, and they should be ready to install. Well, here's the final result. I got the parts all finished. They turned out really nice. So what I'm going to do is I'm going to install these now on this bottom mount before I take this mount off to do all the rest of the cleanup and painting that I need to do. I think I'm just going to bolt this in permanently with the lock washers and everything that I have, because I don't see that there's any reason I'm going to have to come back and mess with this mount again. Obviously, I'll leave the spacers out because they'll be part of the bolt that goes into the bottom mount when I reinstall it after I get it painted. So I'm going to go ahead and bolt these in. That way I can make sure the alignment's correct for what the mount is set to right now for what I drilled these holes to. So I'm going to go ahead and put the bolts and nuts in and move on to the next thing. So part of the process of finishing up frame one here is going to be drilling the rest of the holes into the top skin here for the forward fuselage. I haven't drilled any of the holes into the center support here for the gear. I haven't drilled any of the holes across frame two that go into the top skin. And I also now need to drill the holes for these extra frame one supports that attach to the upper fuselage skin here. So what I'm doing right now is I'm going to put this into place here with the clecos on either side. See if I can from the bottom either drill or mark these holes here for these plates for frame one. I'm also going to draw some lines from the center rivet hole here in the front to the rivet holes here in the back, where I'll do a mark and draw a line across the top and try and mark on this sheet exactly where those rivet holes need to go, including the ones that need to go here across frame two. So that's what I'm going to work on next. I'll show you what it looks like when I get hopefully this in place with everything marked and ready to drill. I finished drilling the holes here for the frame one supports for the upper skin of the forward fuselage. What I decided to do though is I was going to go ahead and start drilling the holes down the center here of this upper skin that go into the upper support for the nose gear assembly. But I ran into a problem. I kind of made a mistake here. I think I've got a workaround, but let's see here. So as you can see, I put flutes in these because I just couldn't get that curve smoothed out, and I thought, well, it'd be easier just to put flutes in, and I measured the number of flutes that I needed. I evenly spaced them across there, but this upper skin here does not go all the way to the back here to frame two. It ends up somewhere in this area. So what ended up happening is that when I started laying out the rivets that were supposed to go up here and the spacing that was supposed to happen, I ended up doing such a good job of putting these flutes in the wrong spot that basically a rivet was supposed to be right where every flute was all the way down here. So what I'm going to do is I'm going to modify the spacing on these rivets in the front here. I'm still going to evenly space them, but I'm just going to actually do one less rivet. Again, it's not a critical thing, so I'm not too concerned about it. It's more important that I get closer to the middle of these spaces in between the flutes than it is to worry about the exact rivet spacing. So you know, I could go ahead and make new upper supports here. I'm not going to do that because these were a real pain to make because they had this lower lip that had to be bent on here along with the upper lip. The curve had to be right. I'm just not going to redo it. And again, because this isn't really a critical thing as far as the exact placement of the rivets, that I'm not too worried about it. This upper skin gets glued around on the sides of the top here. It goes across frame one and gets glued. So I was even considering gluing it onto this upper section here also. But anyway, that's what I'm working on now. I'm just trying to get the rest of this upper skin drilled the way it needs to be. I do have a couple more rivets that need to go here on the either side of the center part of this into frame one. I'm going to go ahead and get those done too. There is supposed to be 2 rivets at the end of these 2 center supports that go down there. So I'm going to try and get all this finished. The other thing I've been working on the CAD drawing is I do want to put some circular access panels in here to be able to get inside this cavity in the front after the skin is installed, because once the skin is installed and the fuel tank's back here, you have no access to any of this area here except for coming through here. But you've also got the the steel motor mount support that's here, so you have very little hand space to come in here, and then you really can't get in from the back because the only access is basically the holes that your legs go through on top of the on top of the fuel tank. So there have been other builders who have also put access panels in here so that you can get down here to the cables that are down here for the pedals. You can get into the nose gear area. You can get into the pedal tray area, and I think all of that's important to get to, not only for inspection, but just to be able to work on anything would be very difficult if those inspection holes aren't there. And adding those inspection holes after the fact is a lot harder, at least for me, because I can just lay this down on the CNC machine and just cut them out really nicely. And I can go ahead and do that right now. I'm not worrying too much about the placement of those. I'm just trying to put them in about this area and trying to get them big enough that I can fit my hand through them. Other than that, it's not really an important thing, other than making sure we've got rivets all the way around the outside, and then we're able to remove a panel with screws. And I'll show you what it looks like when I get all the pieces made. I'll go ahead and cut out the holes that I'm going to use for it right away, but I can actually install the ring that goes around there and the cover plate at any time. I'll cut those out later. So anyway, I'm going to keep working on some of this stuff, and again, try and get this all drilled. I'm not going to install this right away. I'm still going to keep this off until I get the pedals done. But I want to have all the panel, drilled and ready to go so that I can start, riveting some of these things in the front here. And again, like I said, I'm getting these angle supports here installed with the motor mounts and everything else. So it's a good time to finish this up. So I have all the parts now for frame one, at least all of the aluminum parts to finish the preparation for the steel engine mount on frame one. So now that I've got all the parts cleaned up and iodined, I'm going to go ahead and pop rivet these brackets into place, these brackets on top, and go ahead and get these aluminum mounts for the engine bolted into frame one. So let me go ahead and get that done. I'll show you what it looks like when it's done on the front here, and then we'll start working on preparing the steel mount for final installation. I got a few of the parts installed here. The angles in the bottom are riveted in there with the pop rivets, and I started installing these top angles, which I just secured these with the single pop rivet that was a part of frame one that we had to drill out earlier. I was looking at the plans though, and I did notice that they show all of the bolts being installed with the threads out, with the nut side being out. I'm not exactly sure why, and maybe it's easier to get a washer and nut on it that way. But the rule of thumb that they teach you in mechanics school is that you usually want the bolt head facing forward or from the top down. So in other words, bolts are normally supposed to be installed this direction or this direction, primarily so that gravity doesn't have a tendency to just allow the bolt to fall out if it comes loose. Now in this case, they're having us install these backwards. Not exactly sure why. There isn't supposed to really be any difference between the nut side and the head side and which direction it goes on something that's through bolted. But in this case, it might be easier to get a washer and nut on the front here and reach back here with a wrench and hold it than it is to try and put a nut and washer on the back. And really the purpose of the washer being on the nut side is that that's the side you're supposed to be turning and rotating and not the head side. So in this case, I am going to install these this direction with the threads out. This is obviously a part that's connected to the
the engine mounts, if there was any loose bolts, it's going to fall out no matter which direction it's installed. So you will notice down here I did not do that. I installed the bolts front to back, and it certainly would have been easier for me to just try and slip the bolt in through the back here and get the washer and nut on the front. But again, I don't think it matters, but I thought that was interesting to see that in the plans, and I thought I'd mention it. I now have the engine mount installed. I did paint it. What I ended up doing with the paint, though, is I just went and got some, I guess it was Rust-Oleum engine enamel at the local hardware store. I just wanted to get this thing coated so that it was protected from rust, and the reason I chose the engine paint was not because of a temperature issue, but it was mainly because it was considered to be fuel and oil resistant. So I thought that was important, at least in this area of the aircraft, for steel parts. If I'm going to paint it, to make sure that we don't have any issues with gas, dripping gasoline on it or getting oil on it or anything like that. So it turned out pretty good. Again, I'm not really worried about the paint job on it. Just wanted to get it protected from rust. So I'm still missing the lower bolt here on the front. I've got that ordered. Should be here shortly. I did go ahead and get these pins installed. I haven't put the lock nuts on them or anything yet, but I wanted to point out that there was a fairly simple way to clean out these holes. When I got this engine mount from John, these bolts would not fit in here, and the reason they didn't fit in there is because some of the welding around here kind of bled through the tubes that were in here, and so there ended up being some welding material that needed to be removed from the inside. It wasn't a lot, but it was still preventing the bolt from going in. But there's a trick I learned. Let me grab this over here. Trick I learned a while ago, where you can actually take a tube of sandpaper, and if you roll it really, really tight and slip it in the hole, if you rotate it this direction, opposite the way it's rolled, it will tighten up in the hole, and you can actually slide it back and forth in a very tight, tight situation or tight setup here. As long as you keep the ends of this perfectly square, you can have a nice tube that you can use for sanding. You can also rotate it if you want to. Rotate it this direction will loosen the sandpaper. Rotate it this way will tighten it. And if you get it to a point where you can tighten it and actually roll it, you can do a lot of work as far as sanding inside of a hole without messing up the ends of the tube that's here. And it'll take off a lot of material. I've even gotten to the point where I've stuck this in there, kept these edges perfectly square, so I have a nice uniform, squared tube that's in here. And I've actually put a electric drill around the end of it and actually pinched the end of this in a drill and spun it in here with the drill and pushed it in and out. And you can end up with an absolutely perfect hole without using a reamer, which I don't have. I don't have the exact size reamer here. Now, if I had a step reamer, I might have tried to use that, but this works so well. I mean, these things are perfectly tight in here. There's no play, but yet I can slide them in and out easily. And so that really worked well. I actually used this when I was working on Boeing 727s. One of the first jobs I had as a new mechanic is I had to clean all the bolt holes around the entire bulkhead that attached the forward cockpit to the main cabin of the aircraft. And it was an inspection thing that we had to do. We had to pull out every single bolt, and there was, you could only pull out so many bolts at a time per the FAA requirements for the inspection, and you had to clean all the corrosion out of the holes. And this combination of using these tubes and being able to sand out the inside of the holes and also using a Scotch-Brite inside of them, I was able to clean all those holes and clean out all the corrosion without oversizing the holes, which can happen quickly if you try and ream something or drill something out. So this is a technique I learned a long time ago. It works really, really well if you don't have a reamer and you don't have to take out a whole lot of material. I think this is 220. I used 220 sandpaper, but anyway, I cleaned out all these holes that way. Like I said, it worked great. What I am going to do is I'm going to install some NICs on these bolts when I slip these in here, because we've got bare steel on bare steel, and I don't want this to rust over time. So I will install anti-seize on these, and then I've got aircraft 3/8 lock nuts that fit on the back here with a washer, and we'll go ahead and get those installed. I am going to work on cutting out the aluminum mounts that are actually the engine attaches to that bolt to this.
In a previous picture, I think on Instagram, I created an engine mount, but it was just a preliminary one. It was kind of a test run to see if what I was even doing was going to work. I've designed some new mounts that are a little bit lighter, and they actually have a complete circular ring that I'm going to use to attach the cowling to. As you saw before in the other picture, if you saw it, it was more of a half, more of a U shape. I've now got a circular shape that will taper similar to what was in the plans for the original piston engines. And that's what we'll use, again, like I said, to attach the front part of the engine cowling on it and the rear part, which will form after I get this all set up, and we'll figure out how to actually do an engine cowling on this. So I'm going to keep working on a few more of these other things here on the front. We're just going to finish up these last things. I'll go ahead and get these engine supports cut. We'll get those installed, and we'll go ahead and get all the hardware on here and get that completed. And at that point, we'll basically say that the frame one and the engine mount forward installation is completely done. Well, I got a lot of work done today and last night. So today the lower quarter-inch bolt that I've been waiting for the lower engine mount arrived. I installed that. Last night I cut out what is going to be the final form of the engine mounts I'm creating for the turboprop. These are a little bit lighter than the other one that I created, the test one that I did, and I also created a hoop that went all the way around. So this is a perfect circle, very similar to what is in the plans for the piston engine. What I'll do is I'll taper the edge of this, and this will be where we attach the cowling, that'll cover this engine. This will be a spot that I can screw in here at the front. To attach that, I got some cleanup I still need to do on these. Most of it's just rough casting. I'm actually going to try and radius these corners around here on these arms that come out with a router. We'll test it out and see if that works. But anyway, I've got both the engine mounts now installed, not permanently. I did install these bolts that hold the engine mounts in permanently. I've got the lock nuts on here, the aircraft lock nuts. I also installed these, as I mentioned before, with NICs on the shaft that goes through this tube. Again, it was just to prevent corrosion between this steel pin and the tube that's in there. So that seemed to work really well. Boy, you just need a tiny bit of NICs. You just spin it in, and it will just completely cover it as you put the bolt in. So that worked out great. But yeah, this is what the engine mount looks like without the engine in it, and I think it's going to do quite well. It's more than sturdy enough, I believe, for these turboprops. And you may have noticed that I did mount the turboprop to this front flange, and so we've got a lot of the engine behind the front face here, but there's only about 2 pounds of weight that is offset from the balance point, which is probably about right here, resting on the back here. So there really isn't a lot of pressure or a lot of support that these supports here have to even support. So it's not really a critical thing, especially once you get the prop spinner and everything else on the front of here. It almost balances out. So I think this is a good way to mount these, at least on a CriCri. I can't take a video while I'm cutting these types of things out, especially these thicker items that are 1/2 inch thick. I have to babysit this the whole way around. I've got to lubricate it. I've got to vacuum out, the cut channel. It takes every concentration I have just to keep up with the machine as it's cutting these things out, so I don't end up ruining a bit. But anyway, in case you're wondering what these are, if you don't already know, but these are the clamps that go around the engine mount tubes to actually hold basically the airfoil fairing that's going to go between the nose cone and the engines mounted out on the end of the pylon. So we do have a lot of work that we have to do on these as far as drilling out holes to countersink bolts and actually thread some holes, because you actually end up putting one of these on the bottom, one of these on the top, and then you clamp them together with a bolt. So this is one of those items that when I look at somebody trying to do this by hand, this would be extremely time consuming. And then how do you get these parts to look as good as these do when they come out of this machine? I mean, to be able to cut the exact radius of the tube that has to be clamped in the middle here,
Let me go ahead and pop these out. I've got these held in there with tabs right now. Let me cut those out, clean these up, and we'll drill the holes in here so we can complete this part. Alright, I felt like I spent a lot more time than I should have on these, but I do have them finished. I drilled and tapped the holes in here for these clamps that go on the engine mount. I just have washers in the front of this that I use to just clamp it together, because there's supposed to be a little bit of a gap there, because that's where the spring portion is, or at least the part that's taken up once you clamp it around and you tighten these screws down on top of it. But in case you're wondering how these go, so the hole here obviously goes around the tube here, and this is intended to go down in this area somewhere here, and it's supposed to support the airfoil shape that we're going to bend that covers up this this tube for the engine mount. And at the bottom, this is a support to attach that airfoil shape to here, and then at the top, what we have to do is we have to taper this edge to the same shape or curvature of the airfoil at the front here, and then there's just a couple screws, I think one on the top and one on the bottom, that you put on here that secures that airfoil shape that goes across the top here. So I think what I'm going to do is clamp these onto the tube down about where they're going to go. I am a little bit confused at how the nose cone fits in here at the bottom here, and how this airfoil shape, you know, interacts with that, and how we end up with any kind of seal around that. There also seems like there's going to be a gap behind the pipe here, or this engine mount tube, where the nose cone is going to slip over it, but it's going to leave a hole behind here that's not necessarily, from what I can tell, going to be covered up by the airfoil shape, but maybe it will be, because that just has to go past the tube, and maybe it's back far enough. I'm not really sure. But there's some fit things that I'm going to have to worry about. It's one of the reasons why I started working on these, because I started thinking once this was done is, well, how am I going to make this nose cone? How are we going to make a mold for this? I'm assuming it's going to be out of fiberglass when I'm done. But then that started having me look at this airfoil that needs to go in here, because I'd almost like to make these pieces first and then figure out how the nose cone is going to fit in here, or at least kind of work on them in conjunction. And I'm going to kind of work on that next, even though I've got a lot of the rudder pedal stuff and cables and all that stuff that I can work on too. I'm probably in conjunction going to work on this also, because I do want to get this done. Because I am going to have to make a fiberglass mold for the nose cone, so I can already start at least shaping that for now. So let me go ahead and clamp these on there, and I'll show you what they look like when they're done. So I have some extra cap strip that I was using for the foam in the fuselage. And what I'm going to do is cut a length of this to try and simulate the dimensions of the airfoil that's supposed to go around this support bracket here. It's not really listed in the plans as to how big this piece of aluminum has to be, so I figured out based on my CAD drawing that it should be about 366 millimeters all the way around, including a small 8 millimeter basically flat trailing edge that we'll put a few bolts into to secure it. And then it looks like at the nose here I can get somewhere around a 3/4 inch piece of pipe to just bend the nose of it. That seems like it'll be about the right size. So I'm just going to cut a piece of this at 366. I'm going to fold it in half and basically put a radius at the center of it, and just see if I can get it conformed to this shape, and see if that fits well. If that does, what I can do is just cut out a few, you know, full length pieces or full section pieces of that airfoil that we can then bend in a similar fashion. But let me test it out with this just to see if I got the size right, and I'll show you what it looks like when I'm done. 366 millimeters with an 8 millimeter tab on the end, or trailing edge on here. I just put a pop rivet in there, just drilled it, but that's where we're supposed to put some screws to just hold the trailing edge together. But you can see this fits really well. There's supposed to be a screw here and a screw here to hold this together, and you see if I pinch it together right here, it comes out perfect. So I think this is the right size, which is what I wanted to figure out what rectangle sheet I need to cut out to at least start making this airfoil that goes around here. And this looks like it's going to work. So 366 millimeters. So I did a little bit more thinking about the
cover that needs to go over the pylon here, the airfoil shape that we're working on. I think what I'm going to do is I'm going to hold off on this for right now. So the reason I'm going to do that is I think until the nose cone is actually completely finalized and fit to the front of the airplane here around the tubes, I don't think I can go any further, because what I've looked at is that I can take this clamp here and I can move it over here, and I can put another one here and just put 2 in here, and then go ahead and cut that 366 millimeter by about 12 inches in length airfoil and do the shape, and I can just slip it over the end here and fit it on there. And the 12 inches will make it a little bit longer than it needs to be anyway, and I can slide it over the top of my 2 fittings that I've already made that are already the correct shape. I can slide it down here with the nose cone in place, and then I can just shape each one of these airfoils to exactly match the contour of the fuselage and the nose cone so that we get a nice tight fit. We may need to put some kind of seal around the edge of that. I'm not really sure. Again, that's not really covered in the plans. But again, I think going any further with this at this point doesn't make any sense until I actually create the fiberglass nose cone, which is going to take me a while to do. So I'm going to save that for another video. I'm just glad I got these pieces made, because again, that's part of this structure anyway. And we'll go ahead and do the nose cone fairings and those type of finishing things later on. And obviously I got to work on a cowling for this engine, which will kind of be done in the same process. That'll be again made out of fiberglass also. So I'm going to call the frame 1 engine mount installation at this point complete for this video. We'll come back, like I said, and work on another video where we cover some of the finishing things of this. But I'm going to move on now to some of the flight controls, including the rudder pedals. And so again, thanks for watching the video. Appreciate it. Please like the video, subscribe to the channel, and we'll see you in the next video. Thanks.